Multiplication essentially represents repeated addition. If I write 6 times 2, I have 6 groups of 2, so that would be 2 added up 6 times. Whereas 2 to the 6th, so here I'm doing an exponent of 6 instead of multiplying, this represents repeated multiplication. So I'm multiplying by 2 6 times. And so in general, if I write a to the n, I would say a is my base and n is my exponent, and this represents just multiplying by a n times. It kind of sounds weird to say multiplying by a some number of times. It makes more sense if I write like, oh, I have like 5 times 2 to the 6th. Oh, well, I'm multiplying 5 by 2 6 times, right? But if that 5 is not there, like what kind of goes there? Technically, a 1 goes there. And so some people would argue that the definition of a to the n should be you're just multiplying 1 by a n times. This is pretty meaningless for most of the things that we're going to talk about until we get to something like a to the 0, but that's kind of a little bit later on. But just know that this is sort of a thing that people will talk about sometimes. So I want to talk about exponent facts right now. So a to the n times a to the m. What is this equal to? How can I simplify this? Let's motivate this with an example. Let's do 2 cubed times 2 to the 4th. So I have 3 powers of 2 here, or 3 factors of 2 rather. And I have 4 more factors of 2, or 2 to the 4th. And so in total, how many factors of 2 do I have? Right? I'm just multiplying by 2 a bunch of times. Multiplying by 2 3 times here, and then 4 times here. And so in total, I'm multiplying by 4, 3 plus 4, or 7 times. So 2 to the 3 times 2 to the 4 is equal to 2 to the 3 plus 4. And so in general, our fact is that a to the n times a to the m is equal to a to the n plus m. Yeah, and you could also like write this out like in a more general argument too. So a to the n times a to the m, you could write this as a multiplied n times, and then you multiply by a m more times, and so in total you have that this is a multiplied by itself n plus m times. Okay. Next one is a to the n times b to the n. So here our bases are different, but our exponent is the same, versus over here the base is the same and the exponents are different. Okay. So let's do another example. Let's do like 2 to the 4th times 3 to the 4th. So our exponents are both 4 here. Let's write out what this is. So this is 2 4 times, and then 3 4 times. Okay. Now notice there are the same number of 2's as there are 3's in this product. And so I can essentially pair up the 2's and the 3's together, right? And multiplication is commutative, so I can freely change the order of all the 2's and the 3's so that I actually can pair them up like this. And so now I have, instead of 4 2's multiplied by 4 3's, I have 4 2 times 3's all being multiplied by each other, right? So I have 2 times 3 being multiplied 4 times. So 2 times 3, 2 to the 4. to the 4th, okay? 2 times 3, 2 to the 4th. And so in general, a to the n times b to the n is going to be equal to a times b to the n. You could do like a general argument like we did like up here as well, but it makes not quite as much sense as like the concrete example is going to in this particular case. Next thing I want to talk about is exponents being raised to the power of 0. So if I want to raise some number to the power of 0, what does this represent? So again, remember that I argued that a to the n should really represent 1 multiplied by a n times, right? And so if a to the n represents 1 being multiplied by a n times, what should a to the 0 represent? So if I write like 2 cubed, this is 1 times 2 times 2 times 2. 2 squared is 1 times 2 times 2. 2 to the first is 1 times 2. And then 2 to the 0, well, how many times do I multiply by 2? I don't multiply by 2. So 2 to the 0 means I just don't multiply 1 by 2. I just don't do it. I just leave that 1 alone. And therefore, 2 to the 0 should be equal to 1. And this is the same for like any base. Like if this was a 3, like 3 to the 3 cubed, 3 squared, 3 to the 1, 3 to the 0, like it would all be exactly the same, and you would come to the same conclusion that a to the 0 is equal to 1. And that's for any base too. What about 0? Let's do the same thing with 0 even. So 0 cubed is 1 times 0 times 0 times 0. 0 squared is that. 0 to the first is 1 times 0. And then 0 to the 0, according to our definition, would just be, well, I just don't multiply by 1. Or I just don't multiply 1 by 0. I just don't do it, right? So even though all of these are equal to 0, 0 to the 0, according to this definition, has to be equal to 1. So 0 to the 0 sort of fits the pattern of if I were to do like 3 to the 0, that's equal to 1, 2 to the 0, that's equal to 1, 1 to the 0 is equal to 1, and then 0 to the 0 is equal to 1. But it doesn't fit the pattern of like 0 cubed equals 0, 0 squared equals 0, 0 to the 1 equals 0, and then 0 to the 0 would equal 0. It does not equal 0. So 0 to the 0 is definitively not equal to 0. That is like no one disagrees about that. However, some people disagree that 0 to the 0 should equal 1. Some people, like the textbook, actually would say that 0 to the 0 is undefined because it doesn't well, the book's argument I thought was kind of stupid, honestly. They just said like, oh, well, this pattern, it looks like it's supposed to follow the 0 pattern, but it also looks like it's supposed to follow the 1 pattern, therefore it doesn't follow any pattern, so it can't follow any pattern, so it's undefined. I thought that was, I don't know, I didn't like that. But yeah, so some people do give like legitimate arguments for why 0 to the 0 is undefined that are a little bit more mathematically rigorous than like the pattern thing. But most mathematicians would say that 0 to the 0 is equal to 1. That's sort of the consensus. If you check this on Wikipedia, that's kind of what they say. They say that like some mathematical analysts say that 0 to the 0 should be undefined, but most people will go with it's equal to 1. All right, last thing, a to the m divided by a to the n. I'm sort of going to assume that m is bigger than n here, but it actually doesn't have to be. So here we're really just doing like division, so this is a to the m divided by a to the n. So again, let's do an example. Let's do like 2 to the 4th over divided by 2 to the 3rd. So we have 4 2's up top, and I have 3 2's on the bottom. So what is this equal to? So because I'm multiplying by 2 4 times, and then I'm dividing by 2 3 times, when you multiply and then divide by 2, those are just going to cancel out. And so all of these 2's are going to cancel. So I have I start off with 4 2's in the numerator, and then 3 of them cancel out. So how many am I left with? I'm left with 4 minus 3, which is equal to 1 here. So 2 to the 4 divided by 2 to the 3 is equal to 2 to the 4 minus 3. And that holds generally. A to the m divided by a to the n would be, well, you have m a's in the numerator, and then it's going to cancel with n of them in the denominator. So you're left with m minus n total powers of a. All right, if this was like 2 to the 5, then I would have 5 minus 3, 2's left over. This would be like a 5 now. All right, so that's just going to hold for any like m and n. I won't talk too much about negative exponents here, but it is a thing. If I were to do 2 cubed over 2 to the 5th, this is equal to 2 to the 3 minus 5, which is equal to 2 to the negative 2. This is a true fact. This is it does work like this. And that's sort of because negative exponents just means you flip whether it's going to be in the numerator or in the denominator. So 2 to the negative 2 really just means the same thing as 1 over 2 to the positive 2. Right, and then 2 to the negative 1 would be 1 over 2 to the positive 1, or just 1 over 2. 2 to the, if I do 2 to the negative 5, that's like 1 over 2 to the 5th, and so on. And I'll just briefly mention like 1 over like 2 to the negative 3, that is actually equal to 2 to the positive 3. So whenever you see a negative exponent, basically just like change whether it's in the numerator or denominator and then make the exponent positive. I won't get into why that one is true as much because it's a little bit more convoluted than the other things, but you should be aware of that as a general fact.